All right, look at us. We've graduated to word problems for our We Do section. These two problems are actually pulled directly from AP tests. All right, so 12,000 liter tank of water is filled to capacity. At time t equals 0, water begins to drain out of the tank at a rate modeled by R of t, measured in liters per hour, where R is given by the piecewise function R of t equals yada yada. Is R continuous at t equal to 5? Show the work that leads to your answer. So first job, we're looking at R of 5, saying is it defined? So at 5, we're using the top equation. All right, and when you do that, you'll get 3,000 divided by 8, or 375. So R of 5 is defined. So our first criteria is met. Our second criteria says, does the limit exist? Well, the limit from the left of R of t, oh, sorry, this is a t here, and that's an ugly R. I'll fix that. We just did, right? Because the left limit is going to use that top equation, so 600 t, and that's 375. Then we need to do the right hand one. And when you do that, you're going to get 2,718.28. All right. So these two are not equal. So the limit as t approaches 5 of R of t does not exist. And therefore, R of t is not continuous. At t equal to 5. All right. Next up, we've got another problem with some constants going on. So we're looking for two constants now, a and b, such that f of x is continuous everywhere. So for it to be continuous everywhere, since this is three pieces, we have to be continuous in two places. We have to be continuous at that -1 and at 3. So we're going to use the same process as we did on the I do. So we're going to say, well, from the left, it's -1. What do we got? It's 2. And then we have to look at it from the right as we approach -1, because in order for it to be continuous, these two have to be equal. So we've got 2 equals a times -1 plus b. 2 equals -a plus b. All right, and then we're going to have to use the at 3 point as well. So we're going to end up with two equations and then have to use substitution or elimination to solve them. But before we get there, let's just keep on trucking. We're doing from the left. So 3 from the left is going to be that ax plus b again. And we're looking to make that equal to 3 from the right and 3 from the right. Whoopsie, -2. So now I've got a times 3 plus b equals -2. So 3a plus b equals -2. So now I'm using this equation here and this equation here to figure out the values of a and b. So I'm going to do substitution just because I'm partial to substitution and I like that. So if I do substitution here, I solve for b, I would get b equals a plus 2. And then I'm going to substitute that into my second equation. So instead, I'm going to have 3a plus, instead of b, I'm going to put a plus 2 equals -2. 4a plus 2 equals -2. You could also write them above each other and do elimination. It's really your call. So I got a of -1, and then I can just substitute back in to my b, -1 plus 2. Oops. And b then is going to be +1. So a equals -1 and b equals 1. All right. In case you're a substitution person, I'll do it that way too, I guess. Why not? So if you're all set on this and you're like, I got it, I'll do it the substitution way, then you're fine. If you want to see it the elimination way too, keep watching. So we had the two equations, -a plus b equals 2, 3a plus b equals -2. So the elimination is where you make one of the coefficients the same but opposite, and then you add them together. So if I multiply everything by -1, for the top equation, I'll get a minus b equals -2. Then I'll have 3a plus b. Then I combine them, so I got 4a equals -2. Whoa. A equals -1. And then you would plug back into one of the equations. So I'd have -1 minus b, -2, b equals 1. So it gets us to the same place, just a different process. So this was elimination. The way I did it the first time was substitution. Either way works, so pick whichever one you fancy.